Okay. Okay. Morning, everyone. So I am here to provide an update on what has been happening with GlusterD 2. So I'm Kaushal. I am one of the maintainers of GlusterFS, and I maintain GlusterD and GlusterD 2. So today's I'll start with a quick overview of what GD2 is, and then I'll go on to the work we have done and the work we still need to do. Okay, so man, this is not syncing. Okay, so yeah, so what is GD2? GD2 is the new management system for Gluster 4.0. This will not be backward compatible with the Gluster 3.x system. GD2 is from scratch rewrite because it was hard to build in the things that we wanted to do in GD1. We have written it in Go, and GD2 brings in better scalability, better integration mechanics, and eases the maintenance loads of the GlusterFS maintainers, right? So how we do this is, for better scalability, we have changed the way GD2 does its operation across the cluster, how it stores information, and how it communicates with the rest of the cluster. For integration, we have brought in this to make integration easier for external systems. We have an HTTP API right now instead of HTTP management API. So instead of having a SunRPC-based API where it was hard to write code to manage GD2, now you can use the HTTP API, which is supported in a lot more languages, a lot more frameworks, and it's easier to write it that way. We have made it easier for other GlusterFS developers to integrate their features into GD2. And yeah, in the same way, we have also made it easier to maintain stuff that is getting added into GD2 by trying to add less stuff into GD2. So as I said, we are going to be using GD2 with Gluster 4.0. So for Gluster 4.0, we aim to get GD2 to feature parity with GD1. This means for us basically implementing all the commands that GD1 supports right now. So this would be all your volume cluster management commands and all your volume management commands. We want to stabilize it as much as possible. And as a part of the stability, we want to have proper recovery mechanisms, because the way we structure our cluster now is slightly different. So it's not as simple as just restarting GD2 everywhere once the cluster, restarting GD2 everywhere to recover from any sorts of failures. But we'll try to make it as easy as possible. There'll be some preliminary automatic volume creation support. We'll try to get that in. We have more information on this in another talk about how we want to do it. So right now we develop GD2 external to the current GlusterFS source tree. For 4.0, we aim to merge it into the main tree. And one specific thing about GD2 is that with the 4.0 release itself, there will be no migration support from 3.x to 4.0. Because yeah, we are targeting on getting the features done. We'll want early adopters to probably use it, but for migration and all, we'll do it later. And then for 4.1 and beyond, yeah, this is when we'll say we aim to support GD2 for a longer time or do a LTM release with Gluster 4.1. So again, we aim to stabilize a lot more. We aim to improve our documentation much better, make our documentation much better. And with 4.1, we'll be bringing in migration support. So the migration support would be creating migration scripts that allows us to automatically import the previous cluster and form a new GD2 cluster. We'll try to do fully automatic volume management, as in you just ask for a size and you get a volume back with whatever features you wanted. After that, forming an automatic cluster, as in you add in new servers to your network, and that becomes part of the GlusterFS cluster, and improve logging. So yeah, Vijay was talking about Prometheus and stuff like that. So yeah, we want to bring all this support in beyond 4.1, 4.1 and beyond. So now I'll head on to what we have done till now. At this moment right now, GD2 does basic cluster management. Cluster management is very simple, so we basically got everything done there. So that is adding new peers, removing peers, and managing peers in the cluster. We have done basic volume management, and we have created a new CLI tool. I'll explain each of what we have done in each of these in a moment. Yeah, we have completed that much. But for 4.0, there we still have a lot of things to do. Yeah, we need to implement the rest of the commands. So right now, as I mentioned, we just have basic volume create, start, stop, sort of support, and basic volume set. We don't have any sort of rebalance, heal, all that support built in yet. So this is something we are going to be doing soon. The preliminary automatic volume management hasn't started yet. So this is something still we are working on. And the most important for me right now is to get the recovery steps and cluster recovery steps documented. So once this is done, I'd say I'll feel comfortable for us to go ahead with using GD2 for 4.0. So let's see what we have done for basic cluster management. So the basic cluster management is basically, as I mentioned, expand and shrink clusters. We have peer probe and peer detach implemented. To do this, we had to build several things. We had to build an automatic store because GD2 right now, with GD2, we don't store information on every node, right? So with GD1, we had var lib GlusterD, where you used to store all your cluster information, where we used to store all the volume information, etc. But with GD2, we don't do this. Instead, we store it in an etcd cluster. And yeah, so what we have done is we have built an automatic way to form etcd clusters and manage etcd clusters. We built an HTTP API server. As I said, the management API is an HTTP API server instead of using SunRPC. So external projects will be able to directly talk to the HTTP API server and not depend on trying to run CLI commands to get their operation done. And we have gRPC, which is used for internal communication between GD2s. So yes, a little more about the etcd automatic store. As I mentioned, we use etcd. So we use an embedded etcd within GD2, so you don't need to install etcd separately. And with this embedded etcd, we automatically form clusters as you, an etcd cluster as you probe. So again, you don't need to manually set up an etcd cluster. It's not an extra step for you. The behavior still remains as it was previously with GD1. You just install GlusterD, or you just install Gluster, and you start peer probing, and you get your clusters. Our automatic etcd or cluster formation algorithm also has automatic scaling, as in it takes care of promotion, demotion of etcd servers, and etc. So the automatic etcd algorithm forms an etcd cluster out of a subset of your trusted storage pool and maintains that subset automatically. You don't have to do anything. If needed, you can also use external etcd clusters, maybe if you are running GlusterFS in a container environment like Kubernetes or OpenShift, where you already have etcd clusters for those services running, we could use them. Yeah, so what is missing here is that we don't yet have proper recovery mechanisms built in. You'll have to follow the etcd steps for recovery right now. We want to make it easier and give better information to users. So this is something we'll be doing before 4.0 happens. So what happens with this is that if your whole cluster goes down, recovery is not automatic. You'll need to recover in following a specific set of steps. This is not present yet, but we'll be doing it. We have an HTTP API server. This is an HTTP 1 server right now. It's a REST-like server, not proper REST, because we are not properly following all the REST guidelines. Maybe we should. We'll fix the APIs before we make them, official, before we release. The HTTP server uses JSON. This is a very extensible format, so it allows for us to extend our request and response structures as needed. We have initial TLS support for it, and the HTTP API server runs on port 24007, so which was the previous port that clients used to connect to. In addition, we have a gRPC server. This is used for internal communications only. This is between GD2 and GD2. This is used for your cluster management operations and volume management operations. This is not meant for external consumers to use. It runs on port 24008. Previously, this port we used to serve, I guess, what was that? RDMA stuff, but I don't think we do it now, or it's not required. Okay, we'll check that. Because from what I had asked Talur, previously said we don't actually require it, so that's what we're doing. Yeah, we'll figure that out. Yeah, so that's the gRPC server. This is not available for external consumers, but any internal GlusterD features that we build in will be able to use this to do their operations. So yes, so now for basic volume management, let's move on. What we have done till now is that we have implemented the volume create, start, stop commands. We can create, distribute, replicate, and distribute, replicate volumes right now. But we don't have heal and rebalance implemented yet, so we don't have expand and shrink of volumes. So we are working on that. To implement these commands, we needed to implement a transaction engine. You're going to be hearing transaction engine in a lot of other talks as well. This is a different transaction engine. This is the GlusterD transaction engine, which runs commands or runs operations across the cluster to do management operations. We implemented a way to, there is a dynamic volume set implementation. I'll get to what that does. We have a new volgen implementation that makes it easier to define new graphs, new volume graphs. We have a daemon manager, which provides a standard way to manage all the clusterFS daemons with GD2. And we also had to implement a SunRPC server because we wanted to reduce the amount of work people needed to do to integrate with GD2, right? So we provide some SunRPC services so that clusterFS doesn't need to change. Okay, so let me go to the transaction engine. I've talked about this previously as well. So in simple terms, this runs a series of steps across the cluster, and it only runs them where required. It doesn't run it on all the nodes. This was a problem with the previous transaction mechanism in GD1, where one command would run everywhere. So if you had 1,000 nodes, it would run on 1,000 nodes. So that was a problem there. That hurt our scalability with GD1. This transaction engine also brings in support for undoing operations. So say some steps fails in the middle of your transaction. So the transaction engine can undo the previous steps and clean up whatever failed. This engine also doesn't define any fixed sequence of steps to follow. So with GD1, we had a 4-step process of lock, stage, commit, unlock steps. So all commands had to shoehorn their operations within these 4 steps. We brought in a couple of new frameworks in the previous, in GD1 as well, but again, they had rigid steps built in. But the transaction engine with GD2 has a free-form sequence of steps, so you are free to order steps or create as many steps as you want and order them how you want. This is mainly important to the developers, not for the users. We also we've implemented a flexible volgen. In GD, Walgen is the part which generates the actual volume graphs. So given the volume information, we need to actually generate wall files. To generate wall files, we need to generate the volume graph. And with GD1, the way you defined the graph structure was going into GD1's source and defining the structure there and writing custom functions for each graph that you wanted. This was a little hard for everyone to do because it took a lot of effort to understand how Walgen worked. But with GD2, we want to make it simpler. So with GD2, for most simple graphs, you just define it in a text file. So you define a graph in the text file. It's just a list of translators that you want. And GD2 has generic graph building functions, which uses this template file and generates the graph, fills in information wherever required, and generates the wall file at the end. So we have generic graph building functions which can generate the simple graphs. When we require, say, some specialized graphs which are not really simple, you can you'll be able to define minimal specialized functions which just do the minimum things required to generate those graphs. So right now, Walgen can generate the basic volume type graphs for dist, replicate, distrep, and we haven't implemented the templates for other graph types yet, as in disperse, but again, Walgen can do that. The dynamic volume set. So why is it dynamic this time is that to get a new option to be available. So say with GD1, if you implemented a new option for your translator, to make it show up for volume set, you would have to modify GD1 code as well to put it into a table that we maintained there. So we wanted to avoid that this time. So what we have done is, this time, instead of maintaining the table ourselves, so GD1 will just read all the required information from the translators themselves. So translators already had a volume options table, a translator options table. All translators maintain their own table. So we just have one source right now, so we'll just read it from the translators options table and build our settable options table. To do this, what? Oh man, I lost Wi-Fi here. Sorry. Let me connect. Okay, volume set. As I mentioned, we are now building up our volume options directly from the Xlaters. We are not depending on Xlater owners to come modify GD2 to build to expose their option. So to do this, we had to do some changes to GlusterFS itself. So where we extended the amount of information that is being provided by the Xlater options table. We went ahead and updated a lot of the Xlaters, but there are still a lot of them remaining. So most of these changes are right now in experimental and master branch. So before release, we'll need to update all of them again. The downside, one of the effects of this change is that with Cluster 4.0, your option keys will change a little bit. Your option keys are going to change. But to make it easier for users, we'll be trying to provide a a way to convert old option keys to the new option keys. This will come with probably 4.1, not 4.0, because that's when we will implement our migration efforts. So we have a standardized daemon manager which can start and manage different daemons that GlusterD needs to manage to. So this provides you with a proper interface to communicate with the daemons. So this is where we use SunRPC to communicate with the daemons. Uh, okay, I'm going to start going faster now. We've also implemented a native Go SunRPC XDR server and clients so that we can talk to existing Gluster FSDs and existing Gluster clients. So they don't need to change to talk to GD2. Again, so yeah, as I mentioned, for clients, it's being used to do wall file fetch and do port map. It's used by daemons for doing the daemon communication. And this runs on port 24007. This is where the client services are run. We have a new CLI. Right now it's called Gluster CLI, but once we actually merge it with GlusterFS 4.0, it will go back to being Gluster. This uses the HTTP management API. And to build our CLI, we built a management API package. This package is a Go package. If anyone wants to write a GlusterFS management or wants to automate GlusterFS management using Go as their language, they can use the API package and directly talk to GlusterD tools instead of using the CLI. Right now, we have the basic commands implemented of the commands that I mentioned earlier. There are some slight changes to syntax. I'll get to that next. So the slight changes to syntax are mainly to improve parsability for us when implementing commands. So this means, problem with GD1 was we had to write a separate parser for each CLI. So instead of that, right now we are going to try to follow the POSIX style of commands where we have hyphen options, flags, and stuff like that, so that we can use the standard packages to parse commands. This will only mean slight changes to the existing syntax, but to help users migrate to the new format, CLI will come with a built-in translator to convert it into the new CLI syntax. So even if you type an old style command, it will convert it to the new style command, and we'll move forward. Yeah, so that's there. So as I mentioned, we have the management API package. This is available for external users as well, as long as you're writing your code in Go. In addition to that, we implemented structured logging to make it easier to parse our logs and provide better information in the logs. We have a initial plugin framework which allows you to write the additional features for GD2. So you'll be able to basically implement a new command as a plugin and get stuff done there. So you'll be able to add new REST APIs, sorry, not REST, new management HTTP API. You'll be able to plug into our transaction frameworks to do your operations. You'll be able to go in as a middleware and change operations, requests, and stuff like that. We have implemented an end-to-end test framework. This is a Go test framework that we did. This is basically just to test GD2. It's not the full cluster. It's not full featured, say like Gluster or anything. But yeah, we have a simple end-to-end test framework so that we can test them, do minimal testing of minimal cluster testing of GD2. We have initial RPMs also built, but we'll be cleaning up the spec files and all before we merge. And yeah, that's it. This is the stuff that we have done till now. We have a lot of stuff still left to do to get to the timeline that which I mentioned for February 2018. But yeah, we are hopeful that we can do that. And I guess that's it. So a little information at the end. So we are currently developing GlusterD2 on Gluster/GlusterD2. It's a separate Git repo. We use the GitHub model right now using pull requests. For questions and queries, you can reach out to the GD2 development team on GlusterDev. If you have any questions right now, I'll take them.
Sure. Thanks, Amy. A few questions around the API. Mm-hmm. Do you guys have a formal schema for the API, the HTTP API?
Not yet, but we'll define that. So I'm thinking of using, what is that, Open API was standardized recently, I think. So using that as the standard to define the API.
All right. I'll catch up on this offline maybe.
Okay, sure.
And is the API extensible in any way? Can an external system extend the API maybe to add more calls, to add more specific functions?
Yeah, so our plugin infra will allow you to add new APIs to the HTTP server. So if you want, you can write a plugin that adds in new information.
All right, thanks. Last question. Is the central store also shared with external systems, or is it?
Yes. So if you want to, we'll give you access to the etcd endpoints, and you can.
Okay.
So there are other parts of GD2 cluster 4.0, like I guess JBR and Rio want to use it for what is that, leader election, so, using etcd. So that will be available to external consumers. Yes.
Other questions? Yes. You said that there is no migration support for the new GlusterD Daemon 2. What does it mean if I use Gluster 3.12, for example?
So there is no migration initially with 4.0, right? So with 4.1, we'll bring in a new migration scripts. So the thing is, you can't have sort of a rolling upgrade that you used to have with 3.x, right? That's not possible because of the way we do things internally has changed a lot. We'll have migration scripts with 4.1, where the migration script will read the old cluster information from probably one node and form a new cluster, GD2 cluster, and pull in all the information and create the volumes as it was. So it's migrating from GD1 to GD2. So it's not automatic. So it's not just that you install Gluster 4 and you get a new Gluster 4 cluster, but there'll be a script to help with that. So it's not automatic. Yeah.
Thank you.
David, you had a question? Okay.
Quick question. How lean is the code base still? One of the things about GlusterD now is that it's kind of hard to make changes because there's a lot going on. So is that something that you're keeping in mind as we have all these new features coming on?
Yeah, so most developers wouldn't need to, so the code has been structured right now so that most developers don't need to touch the core frameworks, right? So those core frameworks would probably be heavy, but you don't need to touch that. If you want to add a new command, you add it as your own Go package that GD2 imports and loads in stuff from that package. So you are concerned with maintenance of your own package. You do stuff in your package. So that should be lean enough for most developers. That's what I feel.
So not so much a question, but a reminder. I'm glad you've tackled the RPM packaging Go in RPMs, but don't forget a lot of our community users are running Debian packaging. So I don't know what's involved to do that.
Okay.
And Debian packaging is not very near or dear to my heart, but
I'll reach out.
Oh, wait a minute. Yes, it is.
You can help me with that. Okay.